Very good evening, students. Today, I'm continuing my last lecture, that is multi-threading. Java supports multi-threading that we discussed in my last lecture. I also discussed the difference between multi-threading and multitasking over there. Thread lifecycle also discussed, and different applications of this life cycle of a thread I have already shown you in programming example. Then after I discussed the thread priority, fine. And we have created our thread by using two approaches. One is by extending thread class and another one is by implementing runnable interface. Both we have discussed in my last lecture. Today, I start my discussion with a method. The name of the method is current thread. What this method does, this method returns a reference to the thread in which it is called. Once again, I am repeating. This method returns a reference to the thread in which it is called. And the general form of this current thread method is static thread current thread. I'm showing you an example where I have used this method. Let me share this shared screen with you. Yes, this one. What I have done over here, thing is that I have created, not I have created, better to say, here this program consists only one thread, that is main thread. Fine. No other thread is created over here. So what I'm doing here, I'm calling this current thread method in this line. That is line number 6. Current thread method I am calling. What this current thread method returns, that is the syntax of this current thread method, rather signature of this current thread method. It returns a reference of a thread object. Fine. And this method is a static method. And this method belongs to the class thread. That's why when I'm calling this method, I have to write what I have to write, class name dot method name. That's because it's a static method. And what it returns, definitely it returns the main thread reference, because I'm calling this method inside main thread. And when I print this t is nothing but the reference of this main thread. So when I'm print the value of t, I'm showing you the output, what it actually shows. Then after what I have done, I am calling another method, that is set name. That is set name. We have a method that is get name. And after that, get name method is used to obtain thread's name. Get name method is used to obtain thread's name. And set name method is used to set a new name to a particular thread. Again, I am repeating, there are two methods. One is get name, another one is set name. Get name method is used to obtain thread's name. Fine. And set name method is used to set a name of a particular thread upon which it is called. So here I am calling the set name method on T. The T is basically return, T is basically points to the main thread. So now the name of the thread, that is main thread, gets changed to my thread. That will be the consequence of this line. And then after I just printed the value of n from 5 to 1. And after each and every printing, I am calling the sleep method for 1000 millisecond time. And as because an earlier lecture I discussed that the sleep method is basically returns, or rather basically throws an checked exception, that is interrupted exception, that is a checked exception. So that's why I must have to write this code inside try block and needs to handle it. So that's why the code is written inside try catch block. And this method definitely, this program definitely prints the value from 5 to 1. And after each and every printing, there is a 1000 millisecond times of this sleeping, rather suspending time. So let me execute the program. Okay. Yes, it is coming. 5, 4, 3, 2, 1. Each and every printing, after printing statement, there is a 1000 millisecond time. There's a sleep method is called for 1000 milliseconds of time. Fine. So that is no doubt regarding this part. Look at the first line of this output. It is coming when the value of T gets printed, it is coming 3 parts. It is coming in 3 parts. Look, first one is main, second one is 5, and third one is another main. Fine. And when I have changed the name of this main thread, I have given the name, it is my thread. So the first output in this 3 output stream, the first output gets changed from main thread to my thread. That is showing in the output. Now my question is very common. What is the meaning of this 3 part of this output? When I'm printing this T, it is coming thread. Within a third bracket, it is coming 3 part. One is main, second part is 5, and the third part is again main. So the meaning of this, by default, the name of the main thread is main. So the first part of this output is actually thread name. And the name of the main thread is by default main. Second part is, it's a priority of the thread, which is the default value. We know what is the priority value. Default value is 5. That means it's a norm priority. Fine. And main is also the name of the group of thread. Main is also the name of the group of thread to which this thread belongs. Main is also the group of the thread to which this current thread belongs. So that's why the third is actually the group of the thread where this current thread belongs. So that's why thread part is also showing out the main. When you have changed the name of this main thread to my thread, the output remains same except the first one. In case of main, it becomes my thread. So I hope you understood what is the meaning of this, rather how this current thread method can be used and what is the purpose of using this method. Now I'm moving to the next part of my lecture, that is synchronization. So before coming to the topic synchronization, let me discuss why this synchronization is required. Then I'm entering the main topic, synchronization. Suppose we have two threads, thread 1 and thread 2. Both the threads are using a shared resource like a file, text file or word file, whatever. One thread is writing some data on that text file, and other thread at the same time it reading or rather scanning the data from the same file. So try to understand the situation. One thread is updating the file, another thread is retrieving some data from that particular file. So that's why that file is called the shared resource with respect to both the threads, because both are using that resource at the same time. And the part of the code for both the threads, the part of the code for both the threads which are used to access that shared resource is called the critical section of that code. It's called the critical section of that code. And if there is no synchronization between this access of these two threads on that same shared resource, the data, rather the output data, could be erroneous. Because try to understand the situation. One thread is updating the data, another thread is retrieving or rather scanning or rather reading that particular data. So if the reading operation is done before that updation, definitely that read data or that scan data is not the correct one. So this is the situation where more than one thread are trying to access a shared resource at the same time. We need synchronization. If we don't have any synchronization, in this case, the output of this program is not the desired one, or rather it may be an erroneous output. So far, we have written the data, rather we have used the data by thread is under methods run, under the run methods. And we already know the run method is basically the heart of the thread. And the data so far we used in different programs that are declared or rather used or defined inside run method. And that is basically its own data. Fine. But if they try to use their method, so now our objective is to access some data or methods which are outside themselves, and more than one thread are basically trying to access that same data or same method, better to say same resource. And that may lead to serious problem. I'm showing you what type of problem that they may face. Java enables us to overcome this problem by using a technique that is called synchronization. Once again, I am repeating, we are trying to use some data and methods that are outside of the thread body, and more than one thread are trying to access that data or methods, better to say resource, at the same time, or rather they are competing with each other to access those resources. And as a consequence, they may lead, rather those threads which are trying to access those shared resource may lead to serious problem. And I will show you a sample program which type of problem they may face. To overcome that problem, Java uses a technique. That technique is called synchronization. How this synchronization technique actually solves the problem, that we have to know. There is a keyword. The name of the keyword is synchronized. I'm again repeating, there is a keyword in Java. The name of the keyword is synchronized. We have to use that synchronized keyword to keep the code, synchronized, which helps to solve such problems by keeping a watch on such locations. I'm again repeating, try to visualize the problem of file reading and writing. I'm synchronizing the method reading and writing at the same time. I have set those two methods synchronized. When these two methods get synchronized, or rather declared as synchronized, Java creates a monitor. Try to understand. When I set those two methods, that read method and update method, rather write method, when I declared those two methods as synchronized, Java creates a monitor and it hands it over to the thread that calls the method first time. As long as the thread holds the monitor, no other thread can enter that synchronized section of code. So what is monitor? It's nothing but like a key. And the thread that holds the key can only open that lock. That is the beauty of this synchronized keyword. When I set this two method synchronized, that means these two methods are basically the shared resource with respect to the thread. There is more than one thread that are running. So when I set this method as synchronized, and one thread which are accessing, which are using that method, it has the key only, rather the monitor it has only. No other thread at the same time cannot access that synchronized part of code. And that synchronized part of code is nothing but basically the critical section that I just mentioned in the first. What is the meaning of critical section? The part of the code which are basically using or rather accessing the shared resources. So we are make that part of code as synchronized. And there is also possible to mark a block of code is also synchronized. Here I will show you only a method as synchronized, but it is also possible to mark a block of code as synchronized. And whenever thread completes its work of using that synchronized method or block of code, then it will hand over that monitor to the next thread that is ready to use that same resource. This is the technique that synchronized method or rather synchronized keyword doing in backend and avoiding the problem if rather competing problem if those two are not synchronized. First, let me discuss what type of problem may arise. Look, this is a example, rather this is a coding example. A method, a class is taken, name of the class is table. Inside that, a printable method is there. This method is not synchronized, try to understand. What this method does, this method is basically showing the value of a multiplication table with respect to value n. N is the input parameter of this method. N into I, matlab n into 1, n into 2, n into 3, n into 4, n into 5. And each and every printing, after each and every printing, there is a sleep method. The sleep method is basically used to make the thread in the block state. That we all know. What is the next part? My thread extends thread. This is my thread 1. I'm creating two thread. And both these two thread have a member that is table T. Table is my main class. Try to understand. Table T. And inside this my thread, we have a run method. There's a constructor my thread 1 and my thread 2. And an object should be passed of type table over this constructor. And that objects to be assigned to T. And that T will call the method printable. So my thread 1 and my thread 2 both got the almost same definition. Fine. One is printable value 5, another one is printable value 100. That is the difference between these two methods, rather these two threads. So try to understand what I'm doing in the main thread. I've created a object of class table, and both this thread, when I'm creating a thread object of my thread 1 and my thread 2, I'm passing the same object as a parameter to this T1 and T2 OBJ. So OBJ, both the thread are using OBJ, same object reference. T1 and T2 are basically objects of my thread 1 and my thread 2, and both have this same object OBJ. And when I'm calling the T1.start and T2.start, so definitely they are actually, start means they are executing the run method. As per earlier knowledge of this thread, we know run is actually the heart of this thread. They're executing their run method, and definitely the printable method gets printed, rather works, and as the output it will show the multiplication table of 5 and as well as 100, but they will not come in a sequence, because this method, the method print table is here. It's a shared resource. Print table is the method, is a shared resource. Why it is shared resource? Because this resource is not as a part of the thread. It's not as a part of this run method, or not as the part of this thread class. They are the outsider. This method is defined the outside of this two thread. So both these two threads are trying to access this print table method at the same time. So they have a competitions, which thread can get access that print table. Definitely they will access that print table method in an interleaved fashion, just like a normal thread. So as a consequence, if you check the output of this program, you will see sometimes it is coming 5's output, sometimes it is coming 100's output. Look, first it is coming 100, then it is coming 5, 10. This is the multiplication table of 5. Then 200 coming, then 15 coming, again coming back to the 5. Then 300 coming, 400 coming, then again 20 coming, then 500 coming. So as because this method is the shared resource, and this shared resource is accessed by these two threads, and as because there is no boundary, or rather no limitations of this accessing shared resource, both the threads are accessing depending upon the availability of that shared resource. So as a result, what is the output comes? The output comes in the output screen, which are not in actual sequence. It should be first 100's multiplication table or 5's multiplication table, or rather vice versa. First 5's multiplication table means one table, one multiplication table completed, then another one. So to make this sequence of this output, we have to set this method as synchronized. I mentioned earlier, there is a keyword in Java which is called synchronized. How this method works, how this synchronized keyword works, that also I discussed in detail. When I set this method as a synchronized, that means Java actually creates a monitor. Better to say it's a key, just like a key, which object, just like a key, the object which are basically first call this method, that object will get that key and can only access that method. No other object, rather thread object, if they try to access this method printable, cannot access it because key is not available to it. After completion of its task, rather after completion of the first object which has its key, if completed, then the monitor transfers from rather handover, not transfers, or better to say handover, the monitor or the key to the next thread, which are ready to use the same resource. So that's why we are getting, as because I have said this method is synchronized, and as a consequence, what is the first thread that I started? T1. What is the T1 threads run method? T1 thread is coming from my thread 1. Try to understand. T1 thread is basically object of my thread 1. In my thread 1 run method, it is actually printable of 5. So definitely we'll get the first 5 multiplication table, then we'll get the 100's multiplication table. Let me execute the program. No. Thing is that here both these two statements started, but somehow T2 dot start, this T2 first get the lock, or rather first get the monitor. T2 first gets the monitor. That's why 100's multiplication table comes first, and then 5 multiplication table. If I again execute this program, it may be the different sequence. Means 5 first, look, now it is coming the different. First it is 5's multiplication table coming, then 100's multiplication table coming. So it depends upon the availability of the processor, rather availability of the what I can say, that monitor. Which object will get that monitor? That object should execute that part of code, rather that shared resource, then it handed over to the next thread. So I hope you understood what is the meaning of this synchronization and why it is required. That is much more important to understand why it is required and how Java overcome this problem using this keyword synchronization. So as a conclusion of this synchronized method, what we can say? We can say synchronized method is used to lock an object for any shared resource. When a thread invokes a synchronized method, it automatically acquires the lock for that object and releases when the thread completes its task. Fine. We are moving to the next topic of this thread class, of this thread multi-threading, that is join method. It's a very important method with respect to thread. Join method is defined under thread class, java.lang.thread class. It provides a method. Name of the method is join. What it does, it allows one thread to wait until another thread completes its execution. Once again, I'm repeating, it's a very important method. It is provided by the thread class. Java.lang.thread class provides the method join method, which allows one thread to wait until another thread completes its execution. If T is a thread object whose thread is currently executing, then T.join will make sure that T is terminated before the next instruction is executed by the program. Once again, I'm repeating, if T is a thread object whose thread is currently executing, then T.join will make sure that T is terminated before the next instruction is executed by the program. So I'm showing you an example for better understanding. Before coming to the example, let me tell about the signature of this join method. Public void join throws interrupted exception. That is the one syntax. Another syntax is public void join within bracket long milliseconds. I've given it in my lecture note. Let me share my lecture notes with you. Yes, I hope it is visible to you. So coming to that topic, this join method I'm talking about. Yes, this one. Public void join throws interrupted exception. This is one syntax. Another syntax is public void join long millisecond throws interrupted exception. Sorry for mistyping, rather miswriting. It will be interrupted exception. So two variation of this join method has. So once again, I'm repeating, it's a method defined by this java.lang.thread class, and which is basically allows one thread to wait until another thread completes its execution. Allows one thread to wait until another thread completes its execution. Fine. So now coming back to our previous programming example. Look what I am done here. It's a run method, class test56 extending thread class. And inside run method, I have to print from 1 to 5, and each and every print before that I have called the slip method. Fine. I have created an object of this test56. One is T1, T2, T3. Forget about this T1.join. So if we don't have T1.join, so what it does, it's a normal thread execution. It depends upon the availability of this processor, which thread will get processor first. And depending upon that situation, as an interleaving manner, T1, T2, T3, all three threads will print the value from 1 to 5, and the output of different execution will get different output. Let me check the output of this current program. 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, 5. This way they are coming. Means T1, T2, T3, again T1, T2, T3, T1, T2, T3. In this way, the program gets executed and gives us the output. Now, what I have done over here, I have called the join method, and this join method is called from T1, by T1, better to say. When T1 is calling that join method, as because this two variations of this join method throws, what it throws, interrupted exception. So that means it's a checked exception. It is declared by this join method. So that's why we need to write it inside try catch block. So that's why I've called this join method inside try catch block, and this join method is called by which thread? T1. What I just mentioned in my discussion, I mentioned join method is used to wait one thread until another thread completes its execution. As because T1 is calling join method, so T1 actually allows T2 and T3 to wait until T1 completes its execution. Once again, I'm repeating here, T1 is calling the join method. As because T1 is calling the join method, so T1 allows to wait T2 and T3. T1 allows to wait T2 and T3 until T1 completes its task. So now if you execute the program, you will show that the output of thread T1 will coming first. Look, 1, 2, 3, 4, 5 gets printed. That is the output of thread T1. So after completion of this thread T1 execution, this up to this much, this is the execution of T1, thread T1. 1, 2, 3, 4, 5, output over. Now T2 and T3 is in picture because T1 completes its task. T2 and T3 will execute as a normal fashion, just like a normal thread, and they are executing in an interleaved manner. That's why this is output comes 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 in this way. Thing is that here I called join method on T1. So thread T1 is not allowing other thread to execute. Rather, in other words, what we can say, T1 allows other threads to wait until it completes its execution. I hope you understood. Next example I'm showing you, that is the second variation of this join method. What is the second variation of this join method? Just explained. It is taking a parameter. In terms of millisecond. Fine. So I'm calling just like previous example. Rest of the code are same. Instead of this, only changed in the line number 16. In this line, I've called the join method on T1. I've used a time that is 1500 millisecond as a parameter to the join method. What is the consequence of using this? Previous one, the meaning of this join method was until and unless T1 completes its task, T2 and T3 cannot enter rather into the processor. But here, the thing is that the join method will work like that. After 1500 millisecond is over, or rather after 1500 millisecond gets elapsed, fine, T2 and T3 can get the processor. So better to say, in the second variation of this join method, this join method enables another thread to wait for certain amount of time, not till completion of the thread object, rather till completion of the executing of that thread object. Now, in the previous case, it enables to wait other threads T2 and T3 till end of execution of T1. But in this case, T1, this join method enables T2 and T3 to wait for 1500 millisecond, not till end of this execution of T1. So as a consequence, what will happen? Try to understand. In the body, in the run method, each and every value of each and every printing of I have called the sleep method for 500 millisecond. So after 3 value of I equal to 1, I equal to 2, I equal to 3, 1500 millisecond gets over. Try to understand. First loop, first iteration, I gets printed value 1. 1500 milliseconds times elapsed. When the value of I equal to 2 gets printed, another 500 millisecond gets over. So total 1000 over. When I value 3, another 500 milliseconds over. So after I value 3, we predict that this join method cannot resist or cannot wait thread T2 and T3 in a queue. So after I value is 3, now 3 threads T1, T2, T3 will get the processor to execute in an interleaving manner. So let me check the output and explain once again. One, two, three, yes. It is coming as expected. Look, this is actually the value coming from T1. 1, 2, 3. Now, T2 and T3 are no more in waiting state. because join method elapsed 1500 milliseconds time. Then T2 say, then output T3, then again T1, 4 is coming from T1, then T2, T3, then T1 again. So T1 is over now. The rest of the output is coming from T2 and T3. So this is the second variation of this join method. So we have two variations of this join method, and it's a very important method defined under java.lang.thread class. I hope you understood this much. Next, I am trying to discuss one more important topic with respect to thread, that is inter-thread communication. Fine. So before trying to discuss this topic, let me understand, rather let me explain what this inter-thread communication is and why this inter-thread communication is required. Inter-thread communication is all about allowing synchronized thread to communicate with each other. Try to understand. When I'm talking about inter-thread communication, it is basically communication between two threads, definitely, but it is all about allowing synchronized threads to communicate with each other. It is allowing synchronized threads to communicate with each other. Fine. Inter-thread communication is a mechanism in which inter-thread communication is a mechanism in which a thread is paused running in its critical section and another thread is allowed to enter in the same critical section, or better to allow to lock the same critical section to be executed. And it is implemented by following methods of the object class. One is wait method, another one is notify method, another one is notify all method. So once again, I'm repeating why inter-thread communication is required in this multi-threading. It is basically all about allowing synchronized threads to communicate with each other. We all know what is the meaning of this synchronized threads. An inter-thread communication is a mechanism in which thread is paused running in its critical section. One thread which executing its critical section, it gets paused. And another thread is allowed to enter in the same critical section. Normally, just we have seen that in case of synchronized, when we use that synchronized keyword with in terms of method or in terms of block, if one thread is executing that synchronized part, no other thread can enter into that synchronized, rather that critical section part. So here, using this inter-thread communication technology, or rather inter-thread communication mechanism, what we can do, we can pause a running thread in its critical section for a time being, and we allow to enter another thread into the same critical section to be executed. That's why this inter-thread communication is required, and it is implemented by the following methods of the object class, not from the thread class. Try to understand. Keep it in mind. The methods I am talking about, these are coming from the object class, not from the thread class. What are those methods? First one is wait, second one is notify, and third one is notify all. What is the use of this wait method? Definitely current thread to release lock and wait until another thread invokes that notify method or notify all method for this object, or a specified amount of time has elapsed. So wait method is basically used to pause that particular thread which is currently executing the critical section. Next question, how many time for how much time it will get paused? Solution is, it may be invoked by calling notify method or notify all method for this object, and it will be invoked. Another thread invokes that notify and notify all methods. At that time, the thread will resume. This thread, which is currently executing, gets resumed. Or another option is there, a specified amount of time may elapsed. You may provide a specified amount of time, just like join method. We may write a specify amount of time. We may specify an amount of time. After elapsed of this amount of time, that thread automatically gets resumed. So wait method is basically used for that purpose. So notify and notify all, definitely there's two methods. Notify method is basically used to wake up a single thread that is waiting on this object's monitor. And notify all methods is basically wakes up all the threads, those are waiting for the object's monitor. If notify method is basically awaken the only one thread which is waiting for the monitor, and notify all methods is basically awaken all the threads. If more than one threads are waiting for that monitor, they awaken all. So that is the difference between notify and notify all. So this, all the things are mentioned in my lecture notes. Once again, I'm sharing it with you. These things I have mentioned in my lecture note. Yes. Inter-thread communication. Look, this is the notify method, notify all method, wait method. These things are already discussed in my lecture note. So now my next question, and very important question, the question may rise in your mind also. Then what is the difference between this sleep method and this wait method? Because both are actually pausing, rather paused the current execution of the thread for certain amount of time, right now? Though this wait method, though the wait method is used in case of synchronization purpose, sleep method is not used in the purpose of synchronization of this thread that I just mentioned. Apart from this, there are the difference. What are the difference? The first point is wait method release the lock. Sleep method doesn't release the lock, because in terms of sleep method, there is no question of the synchronization perspective. So that's why there is no question of releasing lock in case of sleep method, but wait method must release their lock to the another thread so that another thread can enter into the critical section of the code. Fine. Where it is defined, thread class, under thread class it is defined. Sleep method, it is defined under thread class. Wait method, it is defined under object class. So that is the second point. Fine. Wait method release the lock, first point. Sleep method doesn't release the lock. Second point is wait method defined under object class. Sleep method defined under thread class. Third difference, wait method is a non-static method. Sleep method, it's a static method. So the difference is, first point is wait method release the lock. Sleep method doesn't release the lock. It is defined under the object class. Wait method, it is defined under the thread class, that is sleep method. And it's a non-static method, it's a static method that I just discussed. And the last point should be notified by notify or notify all methods. And in case of sleep, after a specified amount of time, sleep is completed. So these are the basic difference between this wait method and the sleep method. Fine. Now we are moving to an example so that this concept of this wait method, it's clear, it will be more clear to you. Okay. Considering a class customer which has only one member, that is amount, has 10,000. Fine. Two methods declared over here. One is withdraw, another one is deposit under this customer class. And both these two methods are synchronized. We all know what is the meaning of this synchronized method. Fine. This method, withdraw method, is taking one parameter, that is amount, and it is checked in this if condition. It is basically we are checking this amount value is less than the current value or not, as because these two parameters are amount, same with the member variable. That's why we have used this keyword over here. So I'm asking this dot amount is less than this parameter value amount or not. If this is less than, that means sufficient balance is not in my account so that we can transfer, rather we can withdraw. Not transfer, but to say it's withdraw. So it's a less balance. So now what to do? We have to deposit more money in the account to withdraw this amount of withdraw, so that we can withdraw this amount from this account. So that's why we call this method wait over here. If sufficient balance is not available, then we are calling this wait method. What wait method does? It basically, one thread is basically executing this synchronized part. Fine. Synchronized part means it is a critical section. It is a critical section. No other thread can enter into it. Try to understand. No other thread can enter into it. So it is calling that method wait. When it is calling the wait method, this thread gets paused. And it will be vacant when other thread will call the method notify. And we have another method that is deposit. Try to understand, we have another method that is deposit. Deposit method is used to deposit some amount in the account. So that's why it is just added to this current amount. This dot amount plus equal to amount. That means current amount. This dot amount means currently the amount you have plus the amount you want to deposit, and amount gets modified. Your current amount gets modified. Fine. Next part, class X extends thread class, class Y extends thread class. Both this class has one member of this customer type. So definitely we have to pass a customer object to this constructor to assign this R value. And this thread, X thread, in the run method, this calling withdraw, and Y thread in run method, it is calling deposit. Try to understand both R is basically the same object. From where we came to know this both are basically same object, because look, when I'm creating the object of new X and new Y, I'm passing C. What is C? C an object of this customer class that I just created. Fine. So first I have created an object of customer class. Fine. Then I pass that object to thread class X and Y. X and Y both are the threads class, because both are extending from class thread, and both this class have two customer reference, and that's why I am passing that customer object to this constructor, so that R gets, rather that member gets pointed to an object. So both the members of this class X and Y, this customer members, is both pointing to the same object. And when I'm calling this start method, definitely the run of this run method of this X and Y class gets executed. And in this run method, inside one run method, withdraw method is called, another run method, it is deposit method is called. So as because the first time I'm calling the X, I'm created the object of class X and then calling the start method on it. So that's why I hope this method will execute it first to withdraw amount 15,000. So when it tries to withdraw amount 15,000, point is that I've created object of customer C. So customer C has a member that is amount. Initially the amount value is 10,000, and I'm trying to withdraw 15,000, which is, this amount is not sufficient in the current balance. So that's why this statement get executed. If block, line number 7, if block gets executed, this dot amount is less than 15,000, because this amount value is the parameter amount, this 15,000, and this dot amount is 10,000. So it is less than 15,000. So what I will do, less balance waiting for deposit, and it is going to the wait method. When it is going to the wait method, definitely another thread can execute its critical section. Another thread can execute its critical section. So which critical section is defined over here? It is calling deposit method. So when it is in pause state, the lock transferred to the another thread. Fine. So deposit method. So deposit method gets called, rather invoked. And how much amount it is deposited over here? 10,000. So after depositing 10,000 in this method, this dot amount plus equal to amount, that means 10,000 get deposited. Previously it was 10,000. Now 10,000 more deposited. So total amount gets 20,000. Deposit completed, and now it is notify method called. When this notify method called, so it will awake the previous thread that gets paused by calling wait method. So it will again awake, and after awaking, what will happen? This amount minus of amount, that means balance that I want to deduct, how much amount I want to withdraw. It is 10,000. So amount 10,000 get deducted from the original amount value, and the current balance definitely 20,000 minus, not 10,000, 20,000 minus 15,000. 15,000 I want to withdraw. So 15,000 will be deducted. So current amount will be 5,000, and finally the result show withdraw completed. Let me check the output. Going to withdraw, fine. That's the first point. Second point is less balance, waiting for deposit. Fine. This part, amount is less than 15,000. 10,000 is less than 15,000. So current balance is 10,000. Fine. Then it is calling wait method and get to the post state. Fine. Then, as because it is calling the method wait, so another thread will execute its critical section. Fine. When it executes its critical section, deposited method will be invoked. So after deposited method, look, going to deposit, this line gets printed, then deposit completed, printed, then it calls the notify method. When it calls the notify method, this thread gets resumed. The thread which calls the withdraw method, right, gets resumed, and the amount gets withdrawn. How much amount? 15,000. 20,000 minus 15,000. So now your current amount is 5,000. Fine. And finally, this line gets printed, withdraw completed. So I hope you understood what is the use of this wait and notify method in this program. And this is actually the implementation of inter-thread communication. I hope this much is clear to you. Thank you. Thank you very much.